I've already got it on the other period, so I'm going to get on this one here in just a few minutes. As soon as class is over, I'll upload it real quick. Unless the internet's down. Okay? All right. -3. It's greater than or equal to -3. All right. So, a couple of things real quick. If we're solving a system of inequalities, of linear inequalities, we're going to graph some lines and we're going to shade some areas. And then we're going to look at what they have in common. So similar when we graph equations, you graph the two lines and you saw where they intersected. This time, because inequalities require shading, we're going to look at what shading areas they have in common. Okay? And so we're going to start by graphing the lines and then go from there. So what form do we need equations to be in when we do what? Yeah, y equals mx plus b, which is that slope-intercept form. Okay. Of these two equations, or inequalities, one of them is already in that form and the other one is not. Okay. So let's start with that first one. Let's go ahead and graph it because it's already in slope-intercept form. And we'll talk about some of the differences between this and just equations as we go through. Okay, so on the first one, we start with graphing the y-intercept. So what is the y-intercept in that first equation? 1. So on the y-axis, we go up to the 1 and we put a dot. And that's our starting point. From there, our slope is what? -1/2. So from there, we go down 1 and to the right 2. And as we've talked about the last few times doing this, you can just keep doing that exact same thing over and over and over again until you run out of space. Okay, what else can you do instead of going that direction? Go up 1 and to the left 2. And it's that same exact thing. Okay. So that's where the line should be. Now, one of the differences when you deal with inequalities is the line is sometimes solid, like we normally draw a line, but sometimes it's dashed. And so what we do is, if the line is either this symbol or this symbol, greater than or less than, then it is dashed. So your line will look like this. Okay? If the symbol is greater than or equal to, or less than or equal to, it is a solid line, which looks like the line we've always drawn. Okay? Both of our lines in this one are going to be solid because they both have the equal to symbol with it. Okay? And the solid line means that line is included in the solution, where a dashed line would not be included in the solution. Okay? So this is a solid line, so I'm going to go and connect the dots. Make the line there. And then we get into the next piece that's different for inequalities. Shading. So let's go back to the inequality. What does it say, that first one? It says y is what? Well, what's this symbol right here?
Anything or equal to.
How about greater than or equal to? But that's what it is. So greater than or equal to means we want to shade up on the y-axis. Y has to be greater than something. It's got to go up. And so what you're going to shade is above that line. Okay? Question? I will remind you, for those of you that struggle with which direction the arrow is, if you hold that left hand up, make your little symbol, that's the less than. Using your left hand, that's the less than symbol. Okay, what? Yeah, if I use my left hand, that's less than. If I hold my right hand, that doesn't rhyme, so I don't usually say that. If you hold up your left hand, that's the less than symbol. Alright, next one. The 2x minus y is greater than or equal to -3. Okay? The problem with this one is it's not in slope-intercept form yet. So we need to get it into slope-intercept form. Alright, so to do that, I need to move that 2x to the other side by subtracting it. It's a positive 2x, so that leaves you with -y is greater than or equal to negative 3 minus 2x. Okay. So the next piece is, since y is not by itself yet, it's got that negative 1 in front of it. We need to divide everything by negative 1. So y, and y'all remember on inequalities, if you divide both sides by a negative number, or multiply both sides by a negative number, the inequality symbol changes direction. So instead of greater than or equal to, it changes to less than or equal to. Okay? And then all the other stuff does is just change the signs. Dividing by a negative 1 changes that to a 3, changes that to a positive 2x. So this says y is less than or equal to 3 plus 2x. Is that right? Fine. Right. So this time, instead of saying mx plus b, it's b plus mx. So just know that the 3 is the b.
Wait, what?
The number, when y is by itself, the number without the x is the b. The number with the x is the m. Yep. And so our b in this case, our y-intercept is 3. So I'm going to go up here and put a dot on the 3 on the y-axis. And then from there, my slope is 2, which means I go up 2 and to the right 1. Or down 2 and to the left 1. And we stated earlier that this is a solid line, so I'll go ahead and draw that line. Now, you'll have rulers tomorrow, so your lines need to be a little bit prettier than these are. Hey, let's go and get our heads up. Not through y'all with heads down. Head up. It's over 70 degrees. You ain't getting outside. It's not outside. It should feel warmer in here because the heat's been running.
Well, I'm hot. I'm hot.
Hey, I'll just be honest with you. I'll be honest with you. It's about 5 degrees warmer up here than it is back there. Just for me walking right there. So if you were that cold, be up in front. All right. Now this says y is less than or equal to. Okay, and with that being the case, I'm going to shade down, which is going to be this direction off the blue one. Blue one. You probably did hit this towards the end of algebra 1. Yeah, this is our pretension. Okay, so now, when you have a system of inequalities, your solution is what they have graphed in common, what they shaded in common. So this line here is included in both. This line here is included in both. And then everything out here is included in both. Okay. Now, real quickly, what about a point way out here? Yeah, well, it's not on the grid, but it would be included because it's definitely above the red line and below the blue line. So that's why these arrows are still pretty important. Those keep going, and so does all of this also. Okay? Forever. And ever. Amen. No, I think this was really old song. All right, next problem. See how quickly this one goes a lot quicker because you don't have to solve anything. All right. Two inequalities. The top one does not have an x with it, and the bottom one does not have a y with it. So what does that tell me about the line?
Not gonna touch.
They may touch.
Oh, they like
Well, what they'll end up being is because there's not a slope on the first one, but we do have a y-intercept, that's going to be a horizontal line. Because the second one only has an x, it's going to be a vertical line. So what you're dealing with when there's only one variable is either going to be vertical line or horizontal line. You won't have any slope or slant to it. Okay? Alright, so let's start with the y is less than 2. We're going to graph the line y equals 2, except the graph is now going to be a dashed line because there's not an equal to symbol with it. Okay? So y is less than 2, y equals 2, is on the, yeah, right there. You go to where y is 2 on the y-axis, and you put a dotted line straight through. Okay? And since it says y is less than 2, we're going to shade below that. Okay. The x is greater than or equal to negative 3. That will be a solid line. But on this one, we're going to go to where the x-axis and go to the negative 3. And it'll be a vertical line through that point. So it'll include all of these points here. So we'll just go draw a straight line down. And then by this point, you should be able to figure out greater than that's going to be towards the right.
I'm confused with that part. Why you shaded
To the right?
yeah.
Because it says x is greater than negative 3.
I also just ain't that in no more.
Well, no, the sign changed, the equation changed, so. Okay. So what's part of the solution? This line up to here, because that's included in both, and then everything below that purple line and to the left of the green line. Okay. Okay, is this purple line included in the solution?
Yes.
No, because it's dashed. Alright. Sorry. It's not because it's not part of this inequality. It is part of this one, but it's not part of the first one. Okay. Because it's dashed, that means it's not equal to that. For this, get her to sleep.
I'm listening.
I know, but if you're not looking, you're not hearing it. So
Oh, I've already been over this last year.
there's a whole lot that we've been over in the past that a lot of us still don't have quite
Don't
yet.
worry about it.
All right. The next one, this will be kind of where we end at today. Talk to me about what you see up here on this one.
Okay, so I see a Y. It's in standard form. I mean, no, it's in slope intercept form.
All right.
And why the rest of the whole form.
Okay. Both of them are already in that form.
I see a greater than or equal
Compare
to.
them. What's the similarities and differences in them?
They both have the same.
They both have the exact same slope. So what kinds of lines does that make them?
They're gonna be the positive.
Let me see.
So they're gonna be.
It starts with a P and ends with parallel. Yeah, the parallel line. Okay, and so that's going to be kind of important. All right, so let's graph that first one. All right, the first one, I go up to the 2 on the y-axis, that's my y-intercept. And from there, I go up 1, 2, 3, and to the right 4. Up 1, 2, 3, to the right 4. Or down 1, 2, 3, to the left 4. Down 1, 2, 3, and to the left. Okay, and it is a solid line. And which direction am I going to shade? Up, so this direction over here. Now, the way I end up doing this when I'm doing this on paper is when I shade the first one, I kind of shade it like this. When I shade the second one, I shade away from it also. But both of those are pretty light. And then whatever they have in common in my solution, I go back and kind of fill in a lot better. Okay, try to make it look at least a little bit neat. If I have to figure out what you're trying to shade, that's not good because I always figure it out as the wrong answer.
I agree, I should.
I should, but some of y'all, when you just start scrapping, you just shade all over the
But
place.
you should know that that's the equal one though.
Alright. Alright, next one. -3 is where the y-intercept is. And then I go up 3 over 4, 3 over 4, down 3 over 4, left 4, down 3, left 4. And this one is a dashed line because it's not equal to it. And then where do I shade?
Oh, boy.
No,
No.
below.
Below,
What's the solution?
No solution.
no solution.
No solution because they don't have anything in common.
They got nothing to talk.
Now,
Smart.
I had somebody earlier immediately say, so if the lines are parallel, there's no solution. That is the case when you're solving a system of equations because they will never intersect. But if this symbol here had been a less than symbol, it would have shaded this way and everything down here would have been part of the solution. This part would not have been, but everything down here would have been. So just because they're parallel does not mean there's no solution. Okay? Then the next question I had was, what if these were the exact same equation? So this one stayed as y is greater than or equal to 3/4 x plus 2, but this one changed to y is less than 3/4 x plus 2.
It's still be no solution.
So the line would still be right here, but it'd be shaded this way. There would still be no solution because the only thing they would have in common would be that line, but this one, the line is dashed, so it's not part of it. Okay. Yeah, that took a little bit further than I was planning on today, but when I actually had 2 students asking that, so I was like, I want to at least bring it up. And so they kind of don't just assume because they're parallel that there's no solution. Okay. I know a lot of us, if I do an example like one, they automatically think, oh, it's like that every time. All right, so expectations for tomorrow. My expectation is that you have spent a little bit of time looking at this stuff. Okay? I prefer it to have been more than just during class time. That's the reason why I put stuff out on the Echo, with the YouTube video and the notes. And I spend time doing that because I want you to have that access. Second, when you come in tomorrow, my expectation is you show me work on every problem, and you do your best in every problem. If you leave it blank, or you show me a complete lack of effort, you will not get credit for that problem.
Keep it going.
Okay? All right, questions on that?
I'll go for tomorrow. Keep it going.
All right. All right, let me hit stop on the recording.